Okay, so I think it's time up. Let's get started. Okay. Can you guys hear me?
Yes, sir.
So you are the anyone else? Okay, Nitish, Jayant. Okay, good. Chandramani, is he aware or Savan? He should be aware of 12.
So yes, sir. He's there. He's added in that list. His name is there for today's class.
Is there? Okay, good. So if he doesn't join, then it's his issue, his problem. Okay. So how many of you are crediting? I think Academic Office sent me the list, but I just wanted to know. Ayush is, crediting it. Rishabh is crediting it, right?
Yes, sir.
Yes,
Ravi,
sir. Yes.
Yes, sir.
you are crediting
Yes,
it.
sir.
Nitish,
Yes, sir.
you are also.
Yes, sir.
Jayant, Jayant, are you there? Okay, Sumit, you are crediting, right? So, 1, 2, 3, 4, 5, 6. Jayant is also crediting. Six people are crediting, and I think Chandramani is also crediting. 7. Okay. Okay, so let's get started today. So, this is lecture 6. In the last class, we were looking at the conditional expectation. So, we saw that expectation can be interpreted as a random variable. So, that is very, very important. So, why is that? For example, expected value of, in the example that we took in the last class, the expected value of x1 conditioned on the sum, it takes different values depending on what the sum is. So therefore, I can think of this conditional expectation as a mapping from omega 3, which is essentially 1 to 12, right? It's an experiment corresponding to, let's say, throwing 2 dice and summing the 2 outcomes, right? And to a real number. And associated with each one of them, there is a probability. We were trying to compute that probability in the last class. Okay, so we also
Sir,
looked at, yes.
sir, I have just one small doubt. Sir, when you are deriving the expression, the conditional expectations,
Okay,
you there take the summation limit, that is x1 or x2. I don't clearly remember that, from 1 to j minus 1, where a is equal to j. But
correct,
sir, x1 can take maximum value 6, but j can
correct.
take maximum value 12. So I didn't understand only that part.
Let me just open that. Which one are you talking about?
Sir, just a little up. So
This one, right?
here, sir, the limit of x1 is from k equal to 1 to j minus 1, where a is equal to j, and s can take value from 2 to 12, but x1
Correct.
can.
So, okay, so supposing s takes value j, okay. What is x? X is x1 plus x2, right? Supposing I say
Yes, sir.
x1 itself takes a value of j, what should be x2?
Sir, okay.
It should be
It
0,
should
right?
be less than j,
So
yeah.
what is the probability that x2 equal to 0? 0, because there is no side called 0, right, in your dice, right? If you
Yes,
throw
sir,
a
okay,
dice,
sir.
is it possible to get 0? No, right? That's the reason. Okay.
Yes, sir.
So this is something that you need to, for example, if you have two random variables x, y, the conditional expected value of x given y equal to y, this is your conditional. You can interpret this as a random variable, and of course associated with that there is an event and the corresponding probability distribution. So I can take expectation with respect to y. This gives me what? Expected value of x. This is called the total expectation law. Okay, so this is something that you should never forget. So it's very, very useful in many, many different contexts while you compute these conditional expectations. Let's look at the validity of this now. So when is it valid? For example, let's say you have a random variable y. This random variable takes any integer y greater than or equal to 1 with probability. So let me write this as py of y equal to 2 to the minus y for all y greater than or equal to 1. Okay. Is this clear? This is the probability distribution. What is this called? This is called geometric random variable. Okay, these are names. Okay, so you know what a geometric random variable is. It means the probability distribution is 2 power minus 5 for y greater than or equal to 1. Okay. Now I'll take another random variable x. Of course, it's dependent on y in the following way. Okay. So this takes the random variable takes value 2 to the y with probability half. Okay, or minus 2 to the y with probability half. Okay, so think of this as an experiment where you draw samples from py of y. I mean, you take the samples from y whose distribution is 2 power minus 5. So the moment you get y, what you do is you take you toss a coin. If it is head, you say 2 power y. If it is tail, you say 2 power minus y. Okay. So now let's look at what is expected value of x given y equal to y. What is the answer? Well, it's easy, right? So it's summation over all x p of y given x, right? Sorry, x given y. X given y is your definition. Is that correct? Is this clear?
Yes, sir.
Yes, sir.
Okay. So let's compute this. Can somebody guess what is the answer? Expected value of x, the average of x when y is given. Suppose y is equal to 1. You draw samples and y happen to be 1. What is expected value of x when y is 1? Given y is 1. Sumit, can you tell me? So
0.
Huh?
0.
Who said 0? Praveen. Okay. Can you tell me why is it 0, Sumit? Or why not it's 0? If it is,
So it will
if it
get
is
cancelled, sir.
Huh?
It will get cancelled out, sir, because we are taking y is equal to 1. So we get two things, sir, like 1 for 2 to the power y is also there and negative of 2 to the power y also there. And multiplication with the x only.
No, it takes value 2 with probability half and minus 2 with probability half, right?
Yes, sir.
Conditioned on y. Therefore, the average should be 0, right? So if you are taking 2 with half the time, minus 2 half the time, on an average you'll get 0, right? That's what we are saying here, right? 2 to the y with probability half plus minus 2 to the y with probability half, which is 0, right? So the
Yes.
conditional average is 0. Okay? Is this fine?
Yes, sir.
Okay. Now, what is Px of x? Can somebody tell me? Px of x. Can somebody tell me what is Px of x?
So it is the probability of x at x.
Yeah, that is correct. This is what you are computing. Probability of x equal to x. So what is that? Can you guys compute and tell me? Don't look at the book. Okay, of course you can look at the book. So he directly writes the answer, but you should tell me why.
So can you move down the screen a little bit? We can.
Yeah, sure. Is this fine? Yeah.
Yes, sir.
So y will take a value anything greater than or equal to 1 with probability 2 power minus y. Okay, so when I say y greater than or equal to y are integers. Okay, so we cannot take any value. So y equal to 1, 2, 3, 4, and so on. How do you compute this? Okay, so in the interest of time, let's look at this. I can write this as probability of x equal to x given y, right, equal to y, into probability of y, right? Now, this is summed over all y. What are the possible values that y can take?
Say integer value. Sorry, sir.
Y equal to 1 to infinity, right? Probability of x equal to x given y equal to y. So whenever y equal to y, so well, if I take y equal to 1, what is the answer? Okay, let me write this again. Whatever, you copy this. So let me write this. Probability of p of x given y, I will consider it to be 1. Okay, into py of 1 plus px given 2 into py of 2 plus and so on, right? Okay, let me also write one more. P of x given 3 into py of 3. This is called the total probability law, right? Conditioned on y and some multiplied by py of y and summed it over all y. What is the answer? Hey, come on, guys! You have to, work these things, and you should be able to say this is not some undergrad first year class. This is a grad level class, right? You should be able to do it very quickly. So, what is p of x given 1 py of y? Can y take value 1? Yes, right? It takes value 1. What will be px? X will take
2 or minus 2.
Exactly, right? So it will take 2 or minus 2. So, right? So I'll write it like this. So p of 2 given 1, right? Py of 1. What is py of 1? 2 power minus 1. Or p of minus 2 given 1, 2 power minus 1, right? This is the first term. What about the second one? Y equal to 2. What is the answer?
Sir,
4
2
or
to the
minus
4,
4.
4 or minus 4.
Huh?
Minus 4. Sir, 2,
X
2
can
to
be
4.
4, right?
Sir, 4.
Huh?
4.
Huh? Given 2 into probability of y equal to 2. So what is the probability that y equal to 2?
Half.
1 by 2 squared, right? This will be minus 2 squared given 2 squared and so on, right? This is how the progression looks like. Do you agree?
Yes, sir.
So now, depending on whether it's 2 or minus 2, 2 squared or minus 2 squared and so on, right? Depending on what x is, what y is, right? So that will give me x, right? So what is, so x can take what? 2 or minus 2, 2 squared or minus 2 squared and so on, right? So how do you concisely write this? You can write this as follows, right? So p x of 2 power k is same as p x of minus 2 power k, but the probability of this happening is 2 power minus k by 2, which is minus 1, right? Do you agree? I want you to check, okay? So this now come out of your undergrad thing. So you have to verify, you have to work really hard, okay? I leave it there. So now let's compute what is expected value of x. So what do you think is the expected value of x? It's summed over all x. X can take what value? 2 power something, right? So k equal to 0, k equal to 1, k equal, it will be 1, 2, 4, 8 and so on, right? So what is the corresponding problem? So it will be x times px of x. So that will be what? What will be the answer? What will be the answer? So you have 1 by 2 because
Yeah.
minus 1 there will be 1 by 2. Summed over all x, I will write it in terms of k, okay? K equal to 0 to infinity. X can take 2 power k kind of a term, and then you have 1 by 2 power k because 2 power minus k is here, right? So they cancel and you get infinity, right? So where is the total expectation law? Expected value of x is infinity. Expected value of x given y is 0. So if you take expectation of 0, you'll get 0, right? So it looks like if you apply total expectation law directly, you will get 0. But expected value of x is infinity, right? Therefore, total expectation law does not hold good, right? Is not satisfied. Okay. Fine, it's not satisfied. So what went wrong? Can somebody guess? What went wrong? Hmm?
Hello.
Yes, tell me. I'm
Sir,
waiting.
will it work for only countable, I mean, finite sample space like that?
Finite, there is nothing, right? It has always, okay, it works finite, but you are saying it doesn't work for infinite or countably infinite?
That's what I'm thinking, sir.
Can somebody tell me what would have gone wrong? Okay, so let's look at this. So the problem is X can take both positive and negative, right? Okay, with equal probability. When it's positive, you have some average, and when it's negative, you have some average, right? Whenever one of them is finite, at least, then things work out fine. Okay, let me explain that. So for example, I can write X into, so I'll call this as X plus. Okay, so what is this? This is max over max of X comma 0. Okay, that means I'm going to take only the positive part of X and 0. Okay, so that means I'm going to take negative. Okay, 0 does not matter because X plus is equal to 0. Well, X minus can also be 0. 0 doesn't matter in this case because whenever you multiply X equal to 0, it does not contribute to the average, so it doesn't matter. Now, if of course, one can compute the probability of this, right? So I can compute, now I can write, for example, X is equal to X plus X minus. Is this clear, everyone?
Yes, sir.
Ayush,
Yes, sir.
is it clear, Ayush?
Yes,
Okay.
sir.
So I can write it as sum of two random variables, right? So if I take expected value, right? Expected value of X, I can write this as expected value of X plus expected value of X minus, right? Do you agree?
Yes, sir.
Minus infinity, it cannot be plus infinity because X minus is negative, right? All the time. So if this happens, then there is an ambiguity, right? So it doesn't converge that way. So at least you want one of them to be finite, meaning if, for example, expected value of X plus is less than infinity, or X minus is strictly greater than minus infinity, then what happens now? If you take expected value of X given Y, let's say some Y equal to Y, if it is conditional, this will be equal to expected value of X. Of course, if expected value of X is finite, if you look at the positive and negative, definitely, I mean, if positive and negative are finite, obviously the expected value of X will also be finite, in which case there is no problem. But if one of them is infinity, what will happen? Suppose this turned out to be infinity and this turned out to be some 2. So expected value of X plus is infinity. So that means the positive values occur more frequently. As a consequence of which the average is infinity. I mean, the higher values occur with more probability. So the expected value of X plus is infinity. Therefore, we expect that expected value of X is also infinity, not just X plus, right? So therefore, this is infinity. So given Y equal to Y, this conditional will also be infinity, and both turns out to be equal. Okay? Is this fine?
Yes, sir.
Is this fine?
Yes, sir.
Okay, so in fact, I would say when I say x plus and x minus, you can also look at the following. Okay, let me just write this in detail, right? So expected value of, let's say, for example, x plus given y equal to something, right? So when will that happen? So for y equal to something, this should be also finite, or one of them should be finite, right? So x minus given y equal to something, this should be greater than minus infinity, right? In other words, if x is positive, non-negative random variable, there is no chance by which this happens, right? Let's go back and see. If x is, suppose this occurs with probability something, let's say 1, okay? So let's do that. Maybe I'll use a different okay, forget it. So this happens with probability 1 and this happens with probability 0, let's say. That means it's a positive random variable, right? What will happen here? This will be 0, so this won't be 0, this will be 2 power y minus 1, right? Now, what will happen here? So this will be 2 power y minus 1. Remember, this is the expected value of x given y. And then you have to average over all y. If you average over all y, what do you get? It will be 1 by 2, right? So 1 by 2 will be the answer. So now, if you look at px of x, given one, so you don't have r here, right? So you only have positive, this first term, right? So you'll get infinity as the, do you still get infinity? Yeah, expected value of x will be infinity, right? You get expected value of x to be infinity. Now let's see what happens here, right? So now you have expected value of x given y is 2 power y minus 1. So what will happen to expect total expectation law? It's overall x times expected value of x given y equal to y, right? So this is x can take what values? Some 2 power something, right? Do you agree? It can take some 2 power something kind of a variable, right? So y or some t, 2 power t kind of a variable. Expected value of x given y is 2 power t minus 1. So sorry, it's 2 power, what did I do? I'm sorry. This is probability of y, right? So what is the probability of y equal to y? 2 power
Minus y.
2 power minus y, right? So this is 2 power minus t into 2 power t minus 1, which is this thing and this thing cancels, and we have 1 by 2 summation over all t, which is infinity, right? So you get infinity here and you also got infinity here, right? If they cancel this. So if it is positive, that is non-negative random variable, no problem. But if it is both, the idea is you split it into positive and negative and assume that it has finite, one of them is finite. Okay, both cannot be infinity. If both are infinity, then the total conditional, total expectation law does not hold good. If one of them is infinity, or let's say the expected value of x minus is minus infinity, then the total expectation law holds good and expected value of x will also be either plus infinity or minus infinity. Okay, so let's write this as a formal statement. So let me write this as a theorem. Okay, so let x and y be discrete random variables if x is non-negative. I'll just skip this. If x has both non-negative and positive values, if x has either expected value of x plus less than infinity or expected value of, I'll just write it in a slightly different fashion, minus of x minus is less than infinity, then expected value of x equal to expected value of x given y equal to y. Okay, that means total expectation law holds good. Is this fine? Any questions?
Yes, sir.
Okay, so now there is a small section in the book called typical values of random variables, mean and median. So I will just leave that as an exercise. You have to read as a reading exercise. Okay, read section. It's a very small section, so 1.5.3. It's almost like half a page or maximum 1 page. So just read that. Okay. Okay. So another notation that we need, it's called the indicator function. Okay. Just to be very formal, I'll write omega f and also assume some probability measure on that. So you
So in
remember
that
what?
statement, so you just made that statement, that in theorem. Please go up a little bit. It's expectation of minus x is greater than infinity, right? Minus infinity.
No,
What is
both
it?
should be finite. That's why.
Yeah, both should be
No,
One
finite.
of them
That's
should be
what.
finite. One of
no, don't you mean expectation of minus x should be greater than minus infinity? Like
Expected value of?
minus x minus should be greater than minus infinity. Is that the
No,
statement?
x minus is what? Minimum of x comma 0, right? Whenever x is negative, we'll take that. Otherwise, we'll put 0.
Yeah, exactly. So shouldn't you be taking
This
finite
is
on the
x
left
minus.
also?
But I'm taking negative, right? Negative of negative is positive. I want
Oh,
that
okay,
to be
okay, okay.
finite.
Got it. Yeah. Okay, got it. Yeah. Okay.
Okay. So let's take an event. Let A belongs to omega. Okay. So you take an event. Okay. So the indicator of A, I'll denote it this way. So indicator of A is 1 if omega belongs to A, 0 otherwise. Well, this is a function of omega. Okay. So the omega is the outcome. Okay, so whenever the outcome or the sample point belongs to the event A, then it's 1, otherwise it's 0. That's why it's called indicator function. It indicates whether the outcome belongs to the set A. Is that fine? Okay, so what can you say about the expected value of this thing, indicator of A, of omega? Can somebody tell me? This is what you do, right? So if you want to approximate any function, right? So you just divide omega into, or approximate any random variable. Basically, a random variable is a function. So you just divide omega into smaller pieces like A1, A2, A3, and so on. It's called partition. And then you approximate the amplitude in each of the partition by some height, right? That's called simple function. You refine the partition so that in the limit the function will be the same as whatever approximation, right? So can somebody tell me what is this?
Probability of A.
So how do you show that?
Sir, it will be 1 for all the entries. Then we are just adding the probabilities of each element in that event A.
Yeah, so this is a random variable. Do you agree? Indicator function is a random variable. Why? Okay, let's probably check that. Can somebody check why is it a random variable in the strict sense? How do you check that?
so it's a function from omega to real number 1 or 0. Like so.
All such that indicator of omega is less than or equal to some x. Okay. Now, you pick an x, for example. Okay, so x I'll pick. I can do one of the two things, right? I can pick any x less than or less than 1. Okay, or greater than or equal to 1 or greater than 1, right? Do you agree? Well, greater than 1 or less than or equal to 1 doesn't matter, right? So I can combine the two and say less than 1 or greater than or equal to 1. Okay. Now, suppose I take any number less than 1. What does that mean? For example, 0.9. You should collect all those outcomes which got mapped to some number less than 0.9. That will happen only when it takes 0, right? When will it take 0? Whenever it is
not in the
a complement, right? Whenever x is less than 1. X greater than or equal to 1, what happens? Is a, right? What happens when, when x is greater than or equal to 1, what happens? If it is 1 or greater, let's say 1.1, it is all those outcomes which get mapped to a number less than 1.1. So if it is 1 or 0, it will be less than. That means omega a or a complement. That is nothing but omega, right? If either a occurs or a complement occurs, a complement or union a, right? That is omega. So whenever x is less than 0, what happens? So this is actually 0 less than x greater than or equal to 1. Okay, x less than 0?
Null set, sir.
Null set, right? So now, if you look at this, a complement definitely belongs to F, right? Because a belongs to, I think I should say a belonging to F. A is an event, okay? A complement also belongs to F. So this is a check. Omega belongs to this is a check. Null set belongs to this is a check. So that means for any x, this thing belongs to F for every x. Therefore, it's a random variable, right? Do you agree? Therefore, I can attach a measure for that and all that. So now let's look at what is the expected value of A of omega, right? What is this? It is all the values that it takes. For example, it takes 0 and 1, right? That's all. X into the probability of this random variable, which is A of omega, equal to x, right? So now x equal to 0, it does not matter, it is 0, right? Whenever x equal to 1, this times probability of indicator of omega equal to 1. So what is that? It's probability of, when will this be 1? Whenever omega belongs to A, right? This is by definition nothing but probability of A. Is that fine? Any questions? No questions?
Sir, I have a question.
Yes.
Sir, when you, like one of indicator of A is of omega is 1, so then it should be sample space only.
No. When will it will be 1 whenever omega belongs to A, right?
Okay.
Whenever this event happens, this will be 1. This will be 1 whenever this event happens. So both are equivalent, right?
Okay, sir.
Yeah. This is nothing but probability of A, right? Chances of A to occur. Any questions? You should be very clear on these things. Because I'm going to use some of these left and right later on. So if you have any doubts, you please ask now. So whatever I am teaching is like the first level undergrad course in probability. Okay, so nothing. It's not really a grad level. Okay. So you should please clarify your doubts right now. Any questions? Okay, I'll assume that you don't have any questions, so I'll move on. Everyone submitted homework, Saman?
Yes, sir.
Everyone? Okay, good. So there will be one more homework just to make sure that you get used to computing things, and then there will be second part which is more of proofs, etc. Okay, so now let's get into what is known as moment generating function. Okay. This is called MGF, moment generating function. So what is, can somebody tell me what is moment generating function? I'll use the notation that this book uses. This is not the usual notation that others use. So this is nothing but expected value of e power rx, which is nothing but x can take any value between minus infinity to infinity. Well, I'm going to define this for a continuous random variable. So e power rx d fx of x. You know what this is, right? This is the Stieltjes integral. Okay, fine. Everyone fine with this definition of this thing? Okay. Now, what can you say about this integrand? So integrand is always positive, right? Therefore, this is always positive. In other words, this random variable is always positive regardless of what x is. So the expected value also should be positive, right? So the other thing that I can say is I can integrate this from 0 to infinity, right? E power rx dfx of x plus I can integrate from minus infinity to 0, right? E power rx dfx of x, right? So now if I want to ask questions about existence of this integral, that means the integral should not be unbounded. That means I want this to be less than infinity, right? This also I want this to be less than infinity, right? Both. So obviously it depends on r, right? Definitely r, if r is 0, both the integral exists. Do you agree? Why? If r is 0, what will happen to the first integral? Can somebody tell me?
It will be so just we will left with the fx distribution function summing over 0 to infinity.
So what will be the answer?
Half.
Half. Why half?
0. No, sir. Sorry.
1 minus fx of x less than or equals to 0.
What do you mean by fx of x less than 0? Fx of x is a function. What do you mean by fx of x less than 0?
No, sir. Probability of x less than 0.
That is the first integral when r is 0?
1 minus
Greater than 0.
Yeah, so when r is 0, this is 1, right? This will be 1. It will be integral of the area from 0 to infinity. That is nothing but
1.
probability of x greater than 0. This will give me probability of x less than 0. So when you add them, you get 1, right? When that you can clearly see here, right? If r is 0, e power 0 is 1, so expected value of 1 is 1, right? So it exists. What about other things? What about what about r greater than or equal to 0? Suppose I pick r greater than or equal to 0, what will happen to this? The second term I need not worry much because e power rx for r greater than or equal to 0, when you integrate from minus infinity to 0, this is like exponentially decreasing, right? It's in the negative portion. No problem with that. Do you agree? Do you agree with this? Right?
Yes, sir.
Yes, sir.
0.
When the only thing that matters is the first integral whenever r is positive, right? Because that is increasing, right? E power rx. Do you agree?
Yes, sir. Yes, sir.
Okay. So now what I will do is I will collect. So again, whenever r is less than 0, then what matters is the second integral. I have to concentrate on the second integral. So what I will do is I'll collect in the set r plus of x, the set of all r such that the integral exists. Okay, is that fine? So in other words, expected value of this is for positive. Okay, e power rx is less than infinity and r positive. Well, equal to doesn't matter, so it's great. Well, I'll put equal to. Okay, r minus of x is all those r such that expected value of e power rx. Well, if r is negative, right? So I'm going to write this r less than 0. So if r is negative, what matters is the second term. If r is negative, you have e power minus r, some minus x, right? X is also negative, you have positive here. So it goes to infinity. So this to avoid that, I want this to be less than infinity. Okay? Is that fine? I want this to be. So that will be an interval, right? So 0 definitely included, and perhaps this is r minus of x. This will be r plus of x, right? Well, this boundary can go to infinity and this boundary can go to minus infinity, okay, depending on the function. You agree? Right?
Yes, sir.
So that depends on what kind of random variable are you looking at, right? It depends on the distribution PDF of the random variable if PDF exists, or CDF of the random variable if CDF. Well, CDF always exists, right? So that means whenever I define this moment generating function, I'm assuming R2 belong to R plus union R minus. Okay, so it should belong to one of these. Otherwise, the integral itself is undefined. Okay, so let's take, okay, so R plus, I'll define it as supremum over all R plus of x. R minus as infimum over all R minus of x. Okay, you know what supremum and infimum is? How many of you know what supremum and infimum is?
Yes, sir.
Nitish? Nitish?
Hello.
Yeah. I'm asking you whether you know or not. I don't know.
Universal intersection.
Infimum and supremum.
No,
you don't know?
no.
Or okay, fine. It's okay. I mean, you should tell. Otherwise, I wouldn't know, right? So whether you know or not. Praveen?
Yes, sir.
You know what is an supremum?
If we come from the infinity, what we get in the set. It's
Intuitively, that is what it is, right? So it's the least upper bound. Okay, fine. Jayant?
Yes, sir, I know.
Okay, Rishabh and Aish Agarwal. Rishabh?
No, sir, I don't know exactly.
Okay, hey, you should have watched the videos, right? No? Didn't you watch the mathematics for data science videos? I would have I have discussed about that in detail. Okay, fine. Rishabh, I'm asking you.
Sir, I was there, sir, but I forgot some. Sorry, sir.
No. I didn't teach you, but the videos that I have sent.
Yes, sir. You mentioned in that video, sir. I remember supremum and infimum, but I don't remember now.
No, you should know these things. Okay, so these are some of the things that we'll use left and right. Ayush, I'm assuming that you know.
Least upper bound means is it out.
I'll explain. I'll explain. So Ayush.
Yes, sir. I read it, sir, but I currently don't remember.
Okay, I'll just give this as an aside. So, for example, you take this set. Okay, it is all the numbers between 0 and 1, 1 not included, but 0 included. Okay, that is what I'm considering. So, what is the supremum? 1. Okay. What is the infimum? 0. What is the minimum? 0, right? Because no number exists in the set that is smaller than 0. So 0 is the minimum. What is the maximum?
1.
1 is not there in the set, right? How can you say that it's maximum?
1 minus 1 tends to 1.
What do you mean by tends to 1?
1 minus epsilon tending to 0.
No, you should give me one number. You cannot say tending to 0, right? So Tending to 0 is 1 again. 1 minus epsilon. Epsilon tending to 0 is 1. What is the minimum? If you say, for example, 1 minus epsilon is your minimum, however small is epsilon, I can take 1 minus epsilon by 2. That is closer to 1, which is larger than 1 minus epsilon. Therefore, whatever you are saying is incorrect, right? Regardless of what epsilon you pick. You can pick epsilon to be 10 power minus 1 followed by 0 still Bangalore, right? From here or from wherever you are, right? So it's still not true, right? So this is not maxima. So what is maxima? What is the maximum element of this set? You should think, right? You are all researchers, right? So none of you are going to do some courses and get out of here, right? All of you are going to write papers. All of you are going to do some research, analysis, etc. So you should tell me now. What is the maximum element of 0 to 1? 1 not included.
We can't define, sir.
Exactly, right? It does not exist. So maxima means you cannot say, what is the class highest mark? What is the maximum marks? You cannot say that is some marks that nobody secured, right? As maxima. You can say always say 100 out of 100, right? So you should say something that is there in the set, that is somebody should have secured it. So similarly here 1 is not the maxima because it's not there in the set. So there is no point that is a maxima. So in such cases 1 turns out to be what is known as supremum. It's called supremum. What do you mean by that? If you look at the upper bounds, right? What is an upper bound of a set? For example, this is 0 and this is 1. 1.5 is an upper bound, 1.3 is an upper bound, 100 is an upper bound, 2002 into 10 power 100 is also an upper bound, and so on. Anything to the right of this set is upper bound. 1 is also an upper bound, right? That means it is all the numbers such that x greater than or equal to 1 is an upper bound, right? Any number in the set is an upper bound for the set A. Let me call this set as A. So now you take the minimum. What is the minimum of this? 1, right? So this is called the supremum. It's the least upper bound. You take the set of all upper bounds and take the least minimum number there. That's called the least upper bound. It's called the supremum. What is infimum of this set? What is infimum of this set?
Greatest 0.
What is minimum of this set?
0.
0, right? Because 0 is there in the set. If you have things like this, for example, 0 is not the minimum because it doesn't belong to the set. So how do you find the minimum infimum here? You take all x such that x should be smaller than y for every y in the set A, right? You take any element in the set A, x should be smaller. For example, minus 0.1 is 1, minus 1 is 1, minus 3.5 is, and so on, right? So I'll take the maximum of the set. What is the maximum? 0, right? 0 also belongs to the set, and therefore 0 is the greatest lower bound. This is the set of all lower bounds, so this is the greatest lower bound. Okay, why do you care about that? Well, in many cases maxima and minima need not exist, but suprema and infima exist, and supremum is a very good approximation for something that you want in practice, right? It's a good proxy for maxima, right? Whatever the best performance that you want to achieve. Similarly infima, right? Therefore whenever you talk about maxima and minima, to be precise, you replace it by supremum and infimum because it always exists, whereas maxima minima, it does not exist. Okay, is that fine?
Yes, sir.
Okay, now this is an aside. You Google and understand it further if you want. So you have R plus and R minus, right? Now what I'm supposed to do is I'll take R between these two, okay, R plus and R minus. This is where the integral exists, and so this gx of R exists if R is between r minus and r plus. And of course, r minus and r plus are, so this is a continuous interval. Okay, it turns out that if you look at r minus r plus, right, everywhere here the gx of r exists. Okay, and the derivative of gx of r with respect to r also exists. Okay, why is that?
Sir, exponential functions are there, no, sir? It's nice function, one of the like real analytic functions.
Correct, but we have dfx of x also, right?
So if d of fx is already differentiable, sir, we have already assumed that fx of x is a nice function.
No, that's not the case, right? Fx of x, I have not assumed that fx of x is differentiable everywhere. No, not really.
So that's why, sir, you have used here the d of fx, no, sir? Differential, you are taking differential of that.
No. That's why, that's the whole point, right? This is just a notation for expected value of x, right?
Okay, sir.
Integral is just a notation, right? So the inner meaning is you have to partition the function, compute the area, and to take the supreme over all refinements, right? Or it depends on where you are. Both upper and lower should match. Then we say that the function is integrable. That
Yes,
the integration, that symbol is just a symbol, right? Okay. I leave this as an exercise. I want you to think about this. So gfx of r exists if this is true, and all derivatives of gx of r exists if r minus, I don't know, somehow I write r minus r power minus 1 r less than r plus. Okay, so this is something that you need to check why. Okay, so now what is the derivative? Let's take the nth derivative of gx of r, or kth derivative of gx of r with respect to r. What will be that? Well, now you have to be careful, right? You are interchanging. Well, it will be easy if I can pull the derivative inside the integral. If I pull that, what will happen? It will be minus infinity to infinity. The first derivative will be r e power rx. The second derivative will be r square e power rx. Kth derivative will be r power k e power rx dfx of x. Do you agree? Well, this x is small. Do you agree? Now, if you take the kth derivative and substitute k equal to 0, what do you get? Sorry, I'm sorry, not k equal to 0, r equal to 0. What do you get? Huh? Hey, what did I do? So, you guys don't even have to be expert here, right? I'm taking the derivative with respect to r, right? Yeah. If I take the derivative with respect to r, x will come out. Okay. So, what happens if I take r equal to 0?
Sir, it is
kth moment.
Yeah, sir. Expectation of x to the power k.
This is expectation of x power k. So that means taking different derivatives. For example, if I take k equal to 1, I get the mean. K equal to 2, I get mean squared, right? Second moment, third moment, fourth moment, and so on, right? Therefore, moment generating function is a nice tool to compute different moments of a random variable. It will come in handy if, for example, suppose x1, x2, etc. are IID. You know what IID is, right? With some finite moments and all that. Then I'll take the sum. Okay, so the Sn I'll take n random variables, add them. I'll call that as Sn. Okay. Then this has MGF GSN of R. What is that? It's expected value of e power r Sn, right? What is that? It's e power r times x1 plus x2 plus x3. I can write it as product, right? Okay. So what is this? x1, x2 are independent. So what happens to e power rx1, e power rx2? If x1 and x2 are independent, any function of those two random variables will also be independent. Okay. So I can write this as product. But since it is independent and identically distributed, this value will be same irrespective of whether it is x1 or x2 or whatever, right? So this will be expected value of e of rx1 whole power n. What is that? This is nothing but gx1 of r whole power n. So that means you just take the moment generating function and take the nth power, you get the moment generating function of sum of random variables. Okay, that is something that is very, very useful in practice, right? Okay, now we have looked at two things, so I'll give that as a homework. If x1 and x2 are IID, then g of x1 and f of x2 are also IID. Here g and f are any two functions. Okay, is this fine? I want you to show that these two are, this is true. What do you mean by independent? So for example, I can do this, right? So probability of x1 less than or equal to small x1, x2 less than or equal to small x2 is probability of x1 less than or equal to x1 times probability of x2 less than or equal to x2 for all x1, x2. Okay, this is what you get. This is the definition of x1 and x2 being independent. So now you have to replace x1 by letter g of x1 and x2 by g of x2. G is any, for example, you can assume g to be continuous, g and f if you want. And I want you to prove this. Okay? Is that fine?
Yes, sir.
Yes, sir.
Okay. I want you to do this before the next class. I want you to submit this homework.
Okay, sir.
Sir, this thing, Chandramani didn't submit his homework. I just checked right now. But he'd have received the mail. He's received the mail because his name is, I've already put in Piazza, so, but he didn't submit the homework.
Can you check once? And of course, if he hasn't submitted, then you'll get 0. That's all. I can't do anything.
Yes, sir. Yes.
This is not high school, right? Or even undergrad first year. He should be responsible enough to submit. If he doesn't submit anything, he'll get, whoever it is, he'll get very low marks. If he gets low marks, then yeah, I don't know. Okay. So just talk to him. I hope he knows that there is a class today.
Yes, sir. He should be. His name is there in the reminder. So.
Huh?
His name is there in the calendar event. The reminder.
Then I think it's his fault. Okay, we cannot do anything. So let's see. I mean, if we have some. Yes, Rishab.
Sir, you mentioned in the previous lecture that you'll give some numerical like homework. So that,
homework,
yeah, that will be good. I think so. We can practice then.
Yes, I'll give before the next class, but that doesn't stop you from doing something, right? So there's so many numericals that it's already there in the book. You can just take a look at it. But anyway, nevertheless, I'll give you homework problems. Before next class, it will be online.
Okay, sir. Okay, sir.
Okay. Yeah. Any questions? So otherwise, we'll stop. Any questions? Next class onwards, we'll look at inequalities. Okay, so like Chernoff, Chebyshev, Markov, and how to apply that to different situations. And then we'll look at law of large numbers, central limit theorem, and that sort of ends this chapter. And then we will move on to the actual stochastic process. Okay.
Okay, sir.
Yeah. Okay, so we'll stop. No more questions, then we'll stop. No questions?
No, sir.
Okay. Okay, then we'll stop. Huh? Thank you.